Yeah, let's start in. In this session, we are going to discuss Master Snowflake introduction as part of Master Snowflake. First, let's start understanding what is Snowflake. As we discussed, a Snowflake is a data warehouse. It is a cloud-based data warehouse. We have already a lot of traditional data warehousing technologies in the market. Why Snowflake is most popular? Why nowadays industry using Snowflake instead of existing data warehousing technologies? First important about Snowflake is it is a cloud-based data warehouse. Cloud-based data warehouse. First important advantage of this cloud-based data warehouse is it separates storage and compute resources. It separates storage and compute resources because of advantage of cloud-based data warehousing, cloud-based data warehousing platform. It separates storage separately and compute resources separately. And advantage of this separating storage and compute resources, scalability. Let's say I want more storage. You can, it uses cloud-based storage technology in the backend. So in cloud-based data storage, there is no limitation. Based on your storage, automatically it will scale your storage. There is no limitation in storage part. Coming to resources. Let's say you send processing request. If it is 1 GB, it uses a few resources to process the data. If it is 10 GB, it uses more resources. If it is 1 TB, it uses more resources to process the data. For this one, we have a concept in Snowflake called virtual warehouse. In virtual warehouse, we will specify a number of resources. We can create virtual warehouse, multiple virtual warehouses. Each warehouse, we can specify number of resources. So in Snowflake Cloud, first important point, Snowflake divides storage separately and processing separately. This processing part in Snowflake terminology, we call it as virtual warehouse. Virtual warehouse means it's a collection of resources. Generic terminology is a processing unit, and Snowflake terminology, we call it as virtual warehouse. Snowflake supports three kinds of cloud sorting. Right now, Snowflake is supporting three clouds. One is AWS, and other one is Azure, and other cloud is Google Cloud Platform. So where we choose this cloud environment while creating Snowflake account. While creating Snowflake account, we have a option of choosing a backend cloud. Performance wise, there is no difference by selecting backend cloud. Let's say for my Snowflake account, I choose an AWS. For your Snowflake account creation, you choose an Azure. Some other Snowflake account creation, they choose an GCP. Performance wise, there is no different. While creating account, we will select a backend cloud. So Snowflake is a cloud data warehouse means it does not have a separate cloud. It uses any one of these three clouds. Any one of these three clouds. Let me discuss. Let me discuss Snowflake If you select Snowflake, backend is AWS Cloud. I said Snowflake uses storage separately and processing separately. Let's say I created a Snowflake account. I created a Snowflake account. I chosen I chosen backend cloud is AWS. If you choose AWS as a backend cloud, then S3 is a storage. It uses AWS S3 is a storage. And processing purpose, it uses AWS EC2 machines. AWS EC2 machines. If I choose Snowflake backend cloud is Azure. If I choose Snowflake backend cloud is Azure, then storage part it uses Azure Blob and processing part it uses Azure VM. Azure VM. If I choose Snowflake backend is GCP cloud, then storage part it uses Google Cloud Storage and processing part it uses Google Cloud Engine as a virtual warehouse. As a virtual warehouse. Up to now, any questions, Steve? Let me explain clearly. Let's say this is my Snowflake. This is my Snowflake. Snowflake is a modern data warehousing tool. Snowflake is a modern data warehousing tool. Snowflake supports unlimited storages. It supports parallel processing. Okay. So whenever we are creating Snowflake account, let's say while creating Snowflake account, we will choose backend cloud. We will choose backend cloud. So if I choose AWS, if I choose AWS, then storage purpose, it uses AWS S3. AWS S3. Processing purpose, it uses EC2 service. EC2 service. If I choose Azure, if I choose Azure as a backend cloud, if I choose Azure as a backend cloud, it uses Azure Blob. Azure Blob for storage, Azure VM concept for processing, Azure VM concept for processing. If I choose GCP as a cloud storage, cloud part, if I choose GCP as a backend cloud for Snowflake, then it uses Google Cloud Storage, Google Cloud Storage for storage, and Google Cloud Engine, Google Cloud Engine for processing, Google Cloud Engine for processing tip. So while creating Snowflake account, we will select a backend cloud. And it supports unlimited storages. It processes your data parallelly. So processing, it processes parallelly so that response is very faster. Here, this processing unit, we call it as virtual warehouse. This processing unit, we call it as virtual warehouse in Snowflake. The advantage of Snowflake is the advantage of Snowflake is it supports unlimited storages. How we are saying it supports unlimited storages? It using three clouds of storages. If I select AWS, it using AWS S3. AWS S3 supports unlimited storage. Azure Blob supports unlimited storage. GCP Cloud Storage supports unlimited storage. There is no limitation in AWS S3. There is no limitation in Azure Blob. There is no limitation in Google Cloud Storage. So that's why we are saying what? Snowflake is supporting unlimited storage. And next one, processing tool. Compared to traditional data warehouses, Snowflake process data very faster. How it will process data very faster? Let's say in Snowflake, we have a concept called virtual warehouse. Virtual warehouse. We have concept called virtual warehouse. So let's say we chosen AWS as our backend cloud for Snowflake. Backend cloud for Snowflake team. It means it creates EC2 instances. We have different virtual warehouse plans. Let's say I am creating virtual warehouse 1 with 2 resources, and I am creating another virtual warehouse 2 with 4 resources. I am creating another virtual warehouse 3 with 8 resources. I am creating warehouse 4, virtual warehouse 4 with 16 resources. 16, 16 resources means 16 uh, EC2 instances. Let's say I have 1 GB data. I have 1 GB data. To process 1 GB data, I do not require this virtual warehouse 4. This virtual warehouse 1 is more than enough. Listen, I have 50 GB data. I have 50 GB data. To process this 50 GB data, let's say virtual warehouse 1 is taking more time. Instead of assigning virtual warehouse 1 to process this one, let's say if I assign virtual warehouse 2, it improves the performance. It processes your data very faster. Listen, so because we have a storage separately and processing separately, these processing, we call it as virtual warehouse. We can create multiple virtual warehouses with different sizes based on your input to data. Based on your input to data, you can choose a right virtual warehouse to process your data. So if you create a virtual warehouse, Snowflake people will not charge. If you use that virtual warehouse to process, then only they will they will charge. We have a separate concept called how Snowflake calculate pricing for storage, how Snowflake calculate pricing for processing. We have a separate sessions. There we are going to discuss There we are going to discuss very clearly about how Snowflake charges for storing, how Snowflake charges for virtual warehouse. Yeah. Till now, any questions to? Is it clear? Okay. Let me add one more point here. Let's say for my Snowflake account, for my Snowflake account, or let's say I am working for XYZ company or XYZ client project. So XYZ client, they created Snowflake. For Snowflake, they used AWS as backend cloud, AWS as backend cloud. And if it is AWS cloud, then S3 for storage and EC2 for processing. EC2 for processing. Okay. So this is Snowflake account created for XYZ client. Now, question is here loading data from data from cloud file system called S3. Cloud file system called S3. So don't think it is from same location. No. Our XYZ client, our XYZ client may have AWS cloud, AWS cloud, AWS cloud account. They are using S3, S3 for their history data. To store history data, they are using AWS S3. So we have a concept of load. We have a concept of load in S3, sorry, Snowflake. Snowflake. Using Snowflake loading, we can load data from AWS S3 to AWS S3 to our Snowflake data warehouse. Here, let's say here for table, let's say we have a folder called EMP. Let's say bucket B1. In that bucket, we have EMP table. In this EMP table, data is stored for employee table. So using load concept, we can connect external storage and we can load the data. This is one way of loading data from AWS S3 to Snowflake. Another way, there is a ETL team in AWS cloud. They uses AWS Glue. They uses AWS Glue. Using AWS Glue, they will perform transformations on this data, then they will load data into Snowflake. This is another way of loading. Like AWS Glue, there are plenty of different ETL techniques to load data from AWS S3 and other cloud file systems. So if you create Snowflake account, if you use AWS cloud as a backend, this Snowflake organization backend creating S3 for storage, EC2 for processing. If you load the data, where it is going to load? Inside this storage location. If you send select query with filter operations, if you send select query with filter operations, let's say I want to select star from employee table where particular department, in that department, salary greater than so and so values. So we send SQL query with multiple filter conditions. Then to process this one, it uses EC2 machines. These EC2 machines going to process this data and returns response back to caller. So to process your select query, we need virtual warehouses based on data size. Based on data size here, we can use right virtual warehouse. Let's say we have created virtual warehouse with two resources, virtual warehouse two with four resources, virtual warehouse three with other sizes. Like this, we can create multiple warehouses based on the size presented in our Snowflake. We can choose a right virtual warehouse to process your data. Okay. So this is main advantage compared to other traditional data warehousing systems. If you use traditional data warehousing systems, we will create a cluster. We make some missions as master missions, some missions as worker missions. So master always takes a request and processes assigned to workers. Workers are responsible for storing the data as well as processing the data. In Snowflake Cloud, storage is separate and processing is separate. If we use AWS Cloud as a backend to Snowflake Cloud, it uses AWS S3 for storage, AWS EC2 for data processing. This processing, we can create multiple virtual warehouses. Processing is a generic term. Virtual warehouse is a Snowflake terminology. Okay, clear, right? Any questions up to now? Is it clear? Yeah. Let me add one more point here. Let's say this is my Snowflake data warehouse. Here I may use AWS, I may use Azure, I may use GCP, I may use GCP for my Snowflake backend. Okay, this is my Snowflake cloud. Snowflake cloud. Now let's see here. We have different sources. We have different sources. Different sources. Source may be file system. Source may be file system. It may be CSV file. It may be JSON file, etc. So these files are presented in local file system. Another one, source may be any RDBMS like MySQL, PostgreSQL, Oracle, etc. Source may be NoSQL like MongoDB and Cassandra, etc. Source may be data warehouse, traditional data warehouse. Source may be any cloud file system like AWS S3, Azure Blob, and GCP Cloud Storage. Storage may be anything. Here, there is a role called data ingestion. Data ingestion. There are multiple technologies in the market like Python and PySpark, AWS Glue, etc. So different technologies used to perform ETL operation, extracting data from different sources, ingest the data into Snowflake data warehouse. Or, uh, as a Snowflake developer, we have load techniques, loading data from external storages to Snowflake using Snowflake techniques. Using Snowflake techniques. Snowflake techniques, we can ingest the data. We can ingest the data from different sources to Snowflake. Once we got data, we call, let's say, that is a raw data. Let's say that is a raw data. On this raw data, we will implement transformations. We will implement transformations and we read raw data, then we load the data to transformed layer. This one become input to our consumers. To perform these transformations, again we have uh, PySpark, Python, Glue, etc. kind of techniques. PySpark, Glue, etc. kind of different techniques to process. This is one way. Second way, we can use Snowflake SQL. Snowflake SQL, Snowflake SQL to perform transformation activities on the raw data, then load it into transform layer. This is one way. Third way, we have different Snowflake-based tools. One popular tool is DBT. Like DBT, there are plenty of tools developed to perform only transformations on the Snowflake data type, on the Snowflake data. So we have multiple. Snowflake itself having a concept called Snowpark. Snowflake itself having a one component called Snowpark. It is like a Spark. It is like a Spark concept to implement pure transformations. Let me add one point here. Let me add one point. One scenario I am explaining it. One of my friend uh, working on AWS data engineering, and he also worked on Snowflake with DBT. He also worked on Snowflake plus DBT. What I did is, in current project, in current project, he mentioned technologies like this. So ETL purpose, he mentioned Glue, AWS Glue. He used AWS Glue and he is saying source is S3, source is S3 and target is Snowflake. Snowflake. Target is Snowflake. Then additionally, he added one more is DBT. He added one more is DBT. And he mentioned both Glue and DBT. He cleared first round and second round successfully. Then he entered into final managerial round. Manager round. When he entered managerial round, the manager is asking why you chosen Glue and DBT in same project to perform transformations. To perform transformations. The main purpose of DBT or Glue for performing transformations. Why you are using two different technologies for same purpose? So if you are using Glue, then why DBT? If you are using DBT, why Glue? So don't put multiple transformation tools in a single project. So Glue purpose is performing transformations on the Snowflake data. And along with that one, we also put SQL queries, Snowflake SQL queries, he mentioned. He written different Snowflake SQL queries to perform, to transforming the data. He used three mistakes. First mistake is he mentioned Snowflake SQL to perform the transformations on the raw data. Second one, he put Glue to perform the transformation. And third one, he put DBT to perform transformations. One is more than enough to perform the transformations. It may be pure Snowflake SQL. It may be AWS Glue. It may be DBT. It may be any other ETL tool to perform a transformations. Okay, clear, right? So first one, we will read data from different sources. We will read data from different sources. First, we will load data, history of data into Snowflake. Snowflake is a modern data warehouse. It is a cloud-based data warehouse. It supports unlimited storages. Earlier, we have a limitation. Let's say, take any traditional data warehouse, there is a limitation in storage. Coming to Snowflake, it supports unlimited storage because it is using backend cloud technologies. Currently, it is supporting three clouds: AWS Cloud, Azure Cloud, GCP Cloud. Okay. So once we ingest data from different sources to Snowflake data warehouse in a raw layer, we apply transformations. To perform data ingestion, we may use different third-party tools like Python, PySpark, Glue, etc. Or Snowflake itself having different techniques to connect different sources, reading data from sources, and loading data into raw layer. On raw layer, we will perform transformations using Snowflake SQL, using different data engineering technologies like PySpark and Glue, or we use DBT, or we use Snowpark, and we have different transformation tools specially available for Snowflake. We have plenty of tools available in the market. And most popular tool is DBT, Snowpark, PySpark, and AWS Glue. And once we perform transformations, instead of directly storing in a target Snowflake location, we will create a stage. In that stage, we will write the data and we will perform validation checks. If everything is valid and data is generated as expected, then we will move that stage data to target or transformed layer. Okay. So is it clear, Snowflake, up to now? Any questions, team? Uh, your voice is very low. Can you speak louder? Yeah.